Hello, welcome back. In this video, we're going to try to estimate a given limit numerically, and here is our function, sine x over x. That is a rational function involving sine function, which is a trig function. To achieve this job, we're going to pick sample values around 0, because this is where we're checking the limit of this function at. So on the right-hand side of 0 and on the left-hand side of 0, we're choosing sample points, and we're going to check the values of the function at those points. So we're going to make a table of values, and eventually we're going to mark those points coming out of the table, and we're going to connect them by a smooth curve to see the pattern. Not to mention, this function is not defined at 0, because if you try to substitute 0 for x, you get sine 0 over 0, which is in fact 0 over 0, and in math this is called an indeterminate form. In other words, you just say that the function sine x over x is not defined at x equals 0. So here are the sample values I picked. So since we are near 0, and we choose points on the left of 0 and the right of 0, I chose the points starting from -0.1, and the max of that on the right hand side is going to be 0.1. And as you see, I slightly get closer and closer to 0. And for this purpose, I chose only 3 points on the right hand side and only 3 points on the left hand side. The next thing is to use your calculator and evaluate the function sine x over x at each sample point. And for your reference, don't forget to set the calculator to radian mode, because these are all radian values. For example, if you want to get the y value for this point, you're going to punch into your calculator sine of -0.1 divided by -0.1, and you're going to have a number eventually. Once you hit the enter, you're going to have a number with a lot of decimal places. What I did is just to keep only 4 decimal places, and as I said, for this problem it should be enough, but you can keep 5, 6, 7 decimal places if you want to, and eventually you do it for every sample point by using your calculator. And what happens is that, as you see from both sides, you get closer to 1, and from this side as well, you get closer to 1. Even though the function is not defined at 0, but the corresponding function values get closer to 1. And we want to see this limit in the graph. So the blue graph is the graph of sine x over x. And those marks here are the marks that I picked for sample points, as you see. When you get closer to 0 from the right or left, as you see, the black marks here, the black marks are getting closer and closer to 1. You can conclude that the limit of this function here is exactly equal to 1. So the limit is defined even though the function is not defined at 0. All right, that's the end of the video. Thanks for watching. I'll see you in another video. Bye.